Elementary Calculus, Lesson 7-3, Sum and Difference Identities. All right, we're going to use this, the sum and difference identities for sine, cosine, and tangent that are right here. I'll explain them a little bit. These are different angles right here. So if you're adding two different angles and they're asking for the cosine of those two angles, what you're going to do is you're going to do the cosine of the first angle times the cosine of the second angle. And if you're adding them together, it's going to be a minus sign here, and it's going to be the sine of the first angle times the sine of the second angle. If it says find the cosine of, or the difference of the cosine of two angles, or you're subtracting two angles, it's going to be the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. So for cosine, when you add two angles together, the sign here is going to be minus. When you subtract two angles, the sign here is going to be plus. Sum and difference identity for sine is similar. When you're adding two angles together, it's going to be the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. If you're adding two angles and they're asking for the sine of them, then the symbol here is going to be plus or addition. If you're subtracting two angles, finding the difference for sine, then it's going to be a minus here. The signs stay the same. Up here on cosine, the signs are opposite. Now for tangent, when you're adding two angles together, it's the tangent of the first angle plus the tangent of the second angle all over 1 minus the tangent of the first angle times the tangent of the second angle. Here on top, the symbols stay the same when you're adding, but on bottom it becomes a minus sign. If you're subtracting, on the top it's going to be a subtraction symbol, on the bottom it's going to be an addition symbol. So let's look. It says on our first example, show producing a counterexample that the cosine of x plus y does not equal the cosine of x plus the cosine of y. We know that because when here they're telling us to add two angles. So up here, using our sum identity for cosine, adding two angles, this is what it should look like. The cosine of the first angle, or cosine of x, times the cosine of y, minus the sine of x times the sine of y. That's what it should be, but that's not what it is. We need to prove that it's not this, that it doesn't equal cosine of x plus cosine of y, by producing a counterexample. So I want to show you, you're going to want to find a counterexample in your first quadrant. It'll just make life easier. 3 pi over 2 and 2 pi. So in our first quadrant, we can pick either a 30, 45, or 60 degree angle in our first quadrant. If you did it in a different quadrant, it would work just fine. You just have to make sure your signs are correct. The reason why you want to use a 35 or a 30, 45, or 60 degree angle is because those are reference triangles, and we know what their sides are. So if I make x equal pi over 3 and y equal pi over 6, okay? Pi over 3 is the same thing as 60 degrees, so it's going to be right here. And pi over 6 is the same thing as 30. It's going to be about here. And if you were to draw lines and make them triangles, I'm going to bring them down here. If you have your 30 degree angle, and you can write a separate triangle if you want, like this, and make this your 60 degree triangle. If you aren't familiar with reference triangles, then go ahead and Google it, or ask me and I can send you just an image telling you what the sides are. But look here, you don't even need to draw the second triangle because this is a 90 degree angle. This is 30 degrees. To find this, you're just going to do 90 minus 30 and you'll be able to figure out what this is. Okay, so it's going to be 60 degrees. So it's really not necessary to have that. The side that is adjacent or next to the 30 degree angle is the square root of 1. The opposite side is 1 and the hypotenuse is 2. And you can use this to find the cosine of pi over 3 or the cosine of 60 degrees and the cosine of y, which is pi over 6 or 30 degrees. Okay, so let's write this out and see what we have. Okay, let's see what this equals. If we do the cosine, we're going to replace x with pi over 3 and y with pi over 6. The cosine of pi over 3, or of 60 degrees, remember pi over 3 is the same thing as 60, the cosine is adjacent, or the adjacent side over the hypotenuse. So the side that's adjacent to 60 is 1, hypotenuse is 2. This is going to be 1/2. Right here, the cosine for pi over 6, or for 30 degrees, adjacent over hypotenuse. So square root of 3 over 2. Add them together. The denominator is the same. You can add them. It's going to be 1 plus the square root of 3 over 2. Now, we have to see if it's the same thing as this side. So I'm going to show you this side. The cosine of, we're replacing x with pi over 3 and y with pi over 6. You need to find a common denominator. We're going to multiply this guy right here by 2 over 2. So the denominator is going to be 6. If you multiply it by 2 over 2, it's going to be 2 pi over 6 plus pi over 6. Now you can add them together. The denominator is the same. It's 2 plus 1, or 2 pi plus 1 pi. 3 pi over 6, which you can reduce this down to 1/2, right? It's been the cosine of 1 pi over 2, or pi over 2. And we have to see if the cosine of pi over 2 equals 1 plus square root of 3 over 2. The cosine of pi over 2 is 90 degrees. Again, these are reference angles. The cosine here is 0. And 0 does not equal that. So we proved that it was not true. If you're not familiar with this, again, let me know, please. But these reference angles, cosine is the x-axis and sine is the y-axis. Because here at 90 degrees, the x is 0, that's why the cosine of 90 degrees, or the cosine of pi over 2, is 0. The sine would be positive 1 because this is the positive side of our x-axis. Okay. Next example says, show that the sum identity for cosine is true for the values used in part A. Move my camera a little bit up for you guys so you can see it better. Okay. We're going to use the sum identity for cosine now, and the same angles for x and y, pi over 3 and pi over 6. And we're going to prove that the sum identity for cosine is true. This is just not what the sum identity is. So the cosine, in this case we have x and y, equals the cosine of your first angle x times the cosine of your second angle y, minus the sine of your first angle x times the sine of your second angle y. We have x equaling pi over 3 and y equaling pi over 6. What I'm going to do, you could replace these guys if you want. I'll do it for you. Cosine of pi over 3 times the cosine of pi over 6 minus the sine of pi over 3 times the sine of pi over 6. We already know what the cosine of x plus y is, but I will write it out. The cosine of pi over 3 plus pi over 6. We already figured that out up here. It's going to be 0. So I'm going to have 0 here. Cosine of pi over 3. Cosine, remember, is adjacent over hypotenuse. And cosine is 60, or pi over 3 is 60. So the side that is adjacent to 60 and over the hypotenuse. We already found it right here. I'm sorry, right here. Cosine of pi over 3 is 1/2. So we're going to replace it with 1/2 times cosine of pi over 6, which we already found was square root of 3 over 2. Minus the sine of pi over 3. Now, sine is opposite side over hypotenuse. All right. The opposite side of pi over 3 again is 60 degrees. So the side opposite of it over the hypotenuse, square root of 3 over 2. The sine of pi over 6 is 30. So opposite over hypotenuse, 1/2. And I think you could see that these guys are the same numbers multiplying together. They're just the numbers are in a different order. It's going to add up to 0 because square root of 3 over 4 minus square root of 3 over 4. I'll show you. 1 times square root of 3 is square root of 3. 2 times 2 is 4. square root of 3 times 1, 2 times 2. This is going to be 0. So we have 0 equals 0. This is true. We proved that the sum identity works for cosine. Now our next example. Use the sum or difference identity for cosine to find the exact value of 735 degrees. So again, on our graph here, 0, 90, 180, 270, and then 360. 735 degrees is not within one circle or one full rotation. If you go around the circle one time, you've gone 360 degrees. 735 is more than that. Well, let's say we go around 2 times. That's 360 times 2 is 720 degrees. We've gone around the circle twice already, still not hit 735. To figure out how much further to go, because it's not going to be much more, just do 735 degrees minus 720. It's going to be 15, which is about right here, okay? This is 15 degrees. It's also 735 degrees. This is like from lesson 7-1, the different cases. This is the first case because the angles end up on they share the same terminal side. It's the same angle. This one's just in the first quadrant. So sine and cosine are both going to be positive. So we have to use the sum or difference identity for cosine to find the exact value of 735 degrees. This right here. Doesn't matter if you add 2 angles together or subtract 2 angles together. What we want to find is we want to find 2 angles that add up to 15 degrees. 2 angles that are reference angles. So 30, 45, or 60. Remember, we have this 30-degree triangle and 60 degrees. They're in the same triangle. We have them, and the adjacent side to 30 degrees is 3. The opposite side is 1. Hypotenuse is 2. If you do a 45-degree angle, this is also going to be 45 degrees, okay? The adjacent side is square root of 2, opposite side is square root of 2, and the hypotenuse is also 2. Okay. Now, we need to figure out what 2 reference angles, 30, 60, or 45, either add up to 15 degrees or subtract to 15 degrees if we were to subtract one angle from the other. We're going to use the difference identity because 30, 45, and 60, all of them are more than 15 degrees. We can't add them together. So if we do 45 minus 30, we get 15. 60 minus 30 is 30. You can't use that one. So we want the cosine of 15 degrees, same thing as the cosine of 45 degrees minus 30 degrees. Okay? We'll use the difference identity for cosine, which is the cosine of our first angle times the cosine of our second angle. Because it's the difference identity, it's going to be a plus sign here. Sine of your first angle times the sine of your second angle. All right, for cosine of 45 degrees, we have our reference triangles here. Cosine is adjacent over hypotenuse. It really doesn't matter which one you use, but the adjacent side right here is square root of 2, and the hypotenuse is 2. Times the cosine of 30, the opposite over hypotenuse. I'm sorry, the adjacent over hypotenuse. Almost did that wrong. Square root of 3 over 2. The sine of 45 degrees is going to be the same as the cosine, okay? Opposite over hypotenuse, square root of 2 over 2. And then the sine of 30 is opposite over hypotenuse, 1/2. Multiply it all together. When you're multiplying radicals, as long as this guy right here, which in this case is a 2 this for the square, as long as it's the same, you can multiply the numbers underneath the radical. So it's going to be 6, square root of 6 over 4, plus square root of 2 over 4. Put them on, they've got the denominator the same, so put them on the same line. Square root of 2 plus square root of 6 over 4. None of these are perfect squares, and nothing else can be reduced. So this is the cosine of 15 degrees, or it's the same as the cosine of 735 degrees. Now it says we're going to use sum and difference identity for sine. It says find this value of the sine of x minus y if, and the way you say this is if x is between 0 and pi over 2. If y is between 0 and pi over 2. Well, I'll come back to this. And the sine of x equals 9 over 41 and the sine of y equals 7 over 25. First thing I'm going to do is going to write the difference identity, because it's minus, the difference identity for sine. The sine of your first angle times the cosine of your second angle minus the cosine of your first angle times the sine of your second angle. Now, referring back to this right here, where x and y are. If you were to graph, and we are working in radians, so if you were to graph everything on your circle, 3 pi over 2. They say that x, the answer for x, is somewhere between 0 and pi over 2. 0, pi over 2. It's in the first quadrant. Also for y, it's between 0 and pi over 2. Y is also in the first quadrant. That's what this is doing. It's giving us limits. Okay, so our limit means that x and y both have to be in the first quadrant, meaning the sine of x must be positive and the sine of y must be positive. Sine and cosine in the first quadrant are both positive, so keep that in mind, and I'll show you what we're going to do. They tell us what the sine of x is. We can plug 9 over 41 in here for the sine of x. We don't know the cosine of y, though. We're going to have to find that. We also don't know the cosine of x. We'll have to find that. They do tell us what sine of y is. It's 7 over 25, so we can replace that with 7 over 25. So I'm going to keep this in mind. I'm going to go down here. We do need to solve for the cosine of y and the cosine of x. I am going to think back to lesson 7-1, our Pythagorean identities, ones that have cosine and sine in them, because we know what sine for x is and we know what the sine for y is for these two different angles. So our Pythagorean identity, which is sine squared plus cosine squared equals 1. I'm going to use that. You could either solve for x or y, it doesn't matter. I'm just going to use x because that's the first one that came, okay? We already know what the sine of x is. We're going to be able to plug that in here. We want to solve for the cosine of x, so we can plug it in here. So if you subtract sine squared x from both sides, that adds up to 0. You have the cosine squared of x equals 1 minus the sine squared of y, or of x, I'm sorry. But we need to find cosine, so take the square root of both sides. Cosine of x equals, when you take the square root of something, you have to do plus or minus, so the positive value and the negative value. But thinking back here, this is where it comes into play. Our limits, x has to be in the first quadrant, so the cosine of x has to be positive. So we're just going to leave it as the positive square root of 1 minus sine squared x. We can now solve for the cosine of x by plugging up right here, sine of x in right here. You could do this all over if you wanted to for the angle y, because we don't know what the cosine of y is. But look, guys, it's going to be the same, okay? This work doesn't change. The angle and all of that is the only thing that changes. So first I'm going to solve for cosine of x by plugging 9 over 41 in for sine. 1 minus 9 over 41 squared. So first thing you do is square it, then subtract it from 1, then take the square root of it. I think you guys can do that. So the cosine of x is 40 over 41. All right. Now, we're going to do the same thing for the cosine of y. We know what the cosine of x is now. The cosine of y is the same formula as this because, again, we just use a Pythagorean identity to solve. You can replace this x with y if you want, and you'll come up with the same conclusion because it's for cosine. So the cosine of y equals the square root of 1 minus sine squared y. Plug in for sine of y, plug in 7 over 25. And square it. Again, all you're going to do, square 7 and square 25, subtract it from 1, take the square root of it. Your answer is 24 over 25. So we know what the cosine of x is and what the cosine of y is. We know what the sine of x is and the sine of y. We can plug it in here and we can solve for the difference identity for these two angles. Sine of x is 9 over 41. Cosine of y is 24 over 25. Cosine of x is 40 over 41. And the sine of y is 7 over 25. Okay, multiply this all out. I'm not going to show you all that. These are bigger numbers. It ends up being a negative number because this ends up being bigger than this. So it's negative 64 over 1025. If you want to write it as a decimal, you're more than welcome to. This right here is our answer. There's several steps, so I want to go over it one more time. Make sure they're asking you for the sum identity. They give you restraints on which quadrant x and y can be in. They don't have to necessarily be the same, okay? Then they tell you what two of these values are. They tell you what the sine of x is and the sine of y. You have to solve for the cosine of both angles. We used our Pythagorean identity to solve and then plugged in, for the cosine of x, we plugged in 9 over 41 for the sine. And for cosine of y, we plugged 7 over 25 in for sine, and we solved. Then you just replace everything in here, and from there it's simple math. Okay? Two more. Use the sum or difference identity for tangent to find the exact value of the tangent of 285. So here's our tangent identities right here. If you haven't taken a screenshot of it, I would take a screenshot of it right now. Okay. The tangent of 285 is, what we are trying to solve. Now I am going to tell you 285 degrees is less than 360. So it is within one rotation. It ends up being right here. I want to say it's about here. 285 degrees. Oh, I'm sorry. Fourth quadrant, 285. It's not over here, guys. 285. 270, and the difference between here is 15 degrees. So it should be similar to that. Okay? So this is in our fourth quadrant. So keep that in mind, okay? But now we need to find two reference angles, either 30, 60, or 45 degrees, where we can, and you always write your reference triangles, where we can either add them together to equal 285 or subtract them together to equal 285. Okay, it's square root of 3, 1, 2, 45, square root of 2, and 2. Okay, we need to find at least one reference angle that we know. So, let's see, 285, if you subtract 45 degrees from it, you get, what is that, 240? Yes, 240, which is over here in this quadrant. It's like, I'm sorry guys, I shouldn't have scrolled that out. But right here in this quadrant right here, this is 240 degrees, which is a reference triangle, okay? Excuse me. So from 180 to 240, it's 60 degrees. This is a 60-degree angle. So you just have to pay attention because this 240-degree angle right here is in the third quadrant. The sine and cosine are going to change, okay? In the third quadrant, they're both negative. So opposite from 60 degrees right here is square root of 3, but it's a negative square root of 3 because this y-axis is negative. And then right here, the adjacent side is 1, but it's a negative 1 because the x-axis is a negative. So keep that in mind, okay? So I'm going to use the sum identity for tangent. the tangent of 240 degrees plus 45 degrees, because if you add those together, you get 285. It's going to be the tangent of our first angle times the tangent of, oh, I'm sorry, it's going to be plus the tangent of our second angle over 1 minus the tangent of our first angle times the tangent of our second angle. Okay, tangent is opposite over adjacent. So for 240 degrees, this guy right here, it's a 60 degree. I already drew the reference triangle actually on the graph. It's opposite over adjacent. Negative square root of 3 over negative 1. Plus the tangent of 45, opposite over adjacent. Square root of 2 over square root of 2. 1 minus, we know the tangent is negative square root of 3 over negative 1. Tangent of 45, square root of 2 over square root of 2. Now just solve. Right here, these guys can reduce to 1. Same thing down here, they can reduce to 1. These are going to become positive because we have 2 negatives. So on top, we have square root of 3 over 1 plus 1. On bottom, 1 minus square root of 3 over 1. All right? You need to simplify it. Okay? You don't have to write it over 1. I guess I wrote it over 1. You don't have to write it over 1. Simplify this. Multiply by the conjugate. Conjugate is on the top and bottom. It's the same numbers. 1 and square root of 3. Difference is the sign between them. Now it's going to be a plus. This is called the conjugate. Okay? When you actually multiply this all out, okay, on top, use FOIL method. And then on bottom, okay, so on top, square root of 3, I'm running out of space, you guys. I'm going to come over here. Right here, square root of 3 times 1 is square root of 3. Square root of 3 times square root of 3 is 3. 1 times 1 is 1. 1 times square root of 3 is square root of 3. And then on the bottom, with conjugates, all you're going to have to do is multiply the first 2 terms and the last 2 terms. Because the 2 middle terms are going to, one's going to be positive, one's going to be negative. They'll add up to 0. So 1 times 1 is 1. Square root of 3 times, or negative square root of 3 times square root of 3 is going to be 3, but it's going to be a negative 3. All right? Up here, you can add your radicals. So we have a 1 here and a 1 here. It's going to be 2 square root of 3 plus 4 over 1 minus 3, which is negative 2. Don't stop there. We did get rid of the radicals on the denominators, but don't stop, because look at this 2, this 4, and this negative 2. You can factor out, okay? You can factor the top and factor the bottom. We're going to factor a 2 out. So if we factor 2 out of here, you have square root of 3. If you factor 2 out of here, you have 2. And then I'm going to factor actually a negative 2. Okay? If we factor a negative 2 out. And then on bottom, factor a negative 2 out, you're just left with 1. Okay? The negative 2's cancel. You have square root of 3 minus 2. And that's your answer. Okay, next one. Verify that the cosecant of 3 pi over 2 plus a equals negative secant of a. Prove that it's an identity. So let's rewrite it down here. Remember in our last lesson, when you're trying to simplify an identity or prove that it's an identity, you need to work with the most complicated side first, and we want to try and get things in terms of sine and cosine. Well, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. I'm actually going to leave the right side by itself. The left side's more complicated. So I'm just going to rewrite this in terms of sine. So it's 1 over the sine of 3 pi over 2 plus a. Because cosecant equals 1 over sine. So I just rewrote it in terms of sine. Now we're going to use our sum identity for sine to solve this. So it's 1 over the sine of our first angle, 3 pi over 2, times the cosine of our second angle A, plus the cosine of our first angle, times the sine of our second angle. And here is the right side. 3 pi over 2 is actually 270 degrees. If you're finding the sine of 270 degrees, it's -1. Remember, the y-axis is sine. And then we have times the cosine of A plus the cosine of 3 pi over 2. It's 0. Cosine is x. X doesn't move at all, okay? So it's 0 times the sine of A. 0 times anything is 0. Right here, -1 times the cosine of A is going to be negative cosine of A. So remember, it's still all over 1. 1 over negative cosine of A equals negative secant of A. One last identity, one last reciprocal identity. We already said at the beginning, secant equals 1 over cosine. So look, 1 over cosine. It's just the negative symbol. It means it's going to be negative. I'm going to rewrite it as negative secant of A equals negative secant of A, which we just, through our work, proved that this, the cosecant of two angles, is the same as the negative secant of this second angle. All right, I will get your homework up for you. Let me know if you have any questions.